Right, hello guys. So today we're going to be doing another strength of materials problem. So problem 3.17 states the solid shaft is formed of a brass for which the allowable shearing stress is 55 megapascals. So let's take a note of that. So tau max equals 55 megapascals. Neglecting the effects of stress concentrations, determine the smallest diameters DAB and DBC, for which the allowable shear stress is not exceeded. Okay, so recall that the equation for the max shearing stress is equal to the torque times C divided by the moment of inertia J, where oops, where C is the radius of the shaft. And the moment of inertia for a circle is given as 0.5 pi times C to the fourth, right? So let's rewrite this equation. So tau max equals torque times the radius times 0.5 or all over zero point 0.5 times pi times C to the fourth. Now we can cancel out one of these. That becomes cube. So solving for C, we get C is equal to cube root of the torque divided by 0.5 pi times max tau. Okay, let's find the diameter for BC first. So we need to find the torque that is acting on shaft BC. So let's go ahead and make a cut right over here. So I have this rod. This is C. I have a cut over here. So I have torque going this way. It's 400 Newton meters. Now I'm going to have a equal and opposite reaction going that way. We'll call it torque BC, right? And it should be pretty obvious that torque BC is equal to 400 Newton meters. So let's go ahead and substitute this into our equation over here. Right, so we got C is equal to the cube root 400 divided by 0.5 pi, and tau max we said earlier was 55 megapascals. So we go times 55 times 10 to the 6, because we just want it in pascals. Okay, and that turns out to be 0.0167 meters, right? And then to get the diameter, you just multiply that by 2, and you'll end up with 0.033 meters or 33 millimeters. And that is for the diameter BC. All right, now let's do diameter AB. So we're going to take a cut over here, right? So again, we have our C, and then this time we have B, cut over here. And we have one here that's going 1200. This one's 400 still. And now we have a new torque AB. So now looking at this problem, you should be able to tell that torque AB is equal to 1200 minus 400, which is equal to 800 Newton meters, right? So now let's use the same equation that we did before. So the cube root of 800 over 0.5 times 55 times 10 to the 6 times pi. And you should get 0.021 meters. And if you multiply that by 2, you get the diameter of AB being 0.0419 meters, or roughly 42 millimeters. There you go.